computer data generated on planet Earth is growing exponentially for many reasons. For a start, retailers are building vast databases of recorded customer activity. Organisations working in logistics, financial services, healthcare and many other sectors are also capturing more data. And public social media is creating vast quantities of digital material. As vision recognition improves, it is additionally starting to become possible for computers to extract meaningful information from still images and video. As more smart objects go online, big data is also being generated by an expanding Internet of Things. And finally, several areas of scientific advancement are starting to generate and rely on vast quantities of data that were until recently almost unimaginable. Big data is often characterized using the 3 V's of volume, velocity and variety. Here, volume poses both the greatest challenge and the greatest opportunity, as big data could help many organizations to understand people better and to allocate resources more effectively. However, traditional computing solutions like relational databases are not scalable to handle data of this magnitude. Big data velocity also raises a number of issues, with the rate at which data is flowing into many organisations now exceeding the capacity of their IT systems. In addition, users increasingly demand data that is streamed to them in real time, and delivering this can prove quite a challenge. Finally, the variety of data types to be processed is becoming increasingly diverse. Gone are the days when data centres only had to deal with documents, financial transactions, stock records and personnel files. Today, photographs, audio, video, 3D models, complex simulations and location data are being piled into many a corporate data silo. Many such big data sources are also unstructured and hence not easy to categorise, let alone process with traditional computing techniques. Due to the challenges of volume, velocity and variety, many organisations at present have little choice but to ignore or rapidly excrete large quantities of potentially valuable information. Indeed, if we think of organisations as creatures that process data, then most are rather primitive forms of life. Their sensors and IT systems are simply not up to the job of scanning and interpreting the vast oceans of data in which they swim. As a consequence, most of the data that surrounds organisations today is ignored. A large proportion of the data that they gather is then not processed, with a significant quantity of useful information passing straight through them as data exhaust. For example, until recently, the majority of the data captured via retailer loyalty cards was not processed in any way. And almost all video data captured by hospitals during surgery is still deleted within weeks. Today, the leading big data technology is Hadoop. This is an open source software library for reliable, scalable distributed computing and provides the first viable platform for big data analytics. Hadoop is already used by most big data pioneers. For example, LinkedIn currently uses it to generate over 100 billion personalized recommendations every week. Hadoop distributes the storage and processing of large datasets across groups or clusters of server computers. Whereas traditional large-scale computing solutions rely on expensive server hardware with a high fault tolerance, Hadoop detects and compensates for hardware failures or other system problems at the application level. This allows a high level of service continuity to be delivered by clusters of individual computers, each of which